Hello friends, welcome to Coding Simplified, and today we'll see about the linked list. So if you see the definition about linked list, so linked list is basically the linear collection of data elements. And so basically these all linear elements are the nodes. So they all are the nodes, and there is one thing that then each node is pointing to the next node. So by the pointer we point it to the next node, and other boxes, these are the elements. So this is a minimal element, so this is like int. It can also has the other variables, like it can has the string as well as the float or whatever variable you can have. But right now this is the example of one element, and then this is a pointer which is pointing to the next element. Now sometime it says that why we use the linked list, right? So this is the most simplest and the most common data structure, and they are used in several other common data types, like they are used in the stacks, they are using in the queues, associative arrays, and X expressions. So that is why we use the linked list when we implement these all data types, right? And what's the benefit of it over the array? So the insertion and deletion is very easy, right? Because in array, suppose if you want to insert an value in middle or in at position, so then you need to shift the all the positions. Same is the case in case of deletion. But when you have the linked list, then it is not necessary to shift. You just go to that position and you delete that, right? And you just point the node to the next node. So that is why we say the insertion and deletion is very easy in linked list. So now we'll start that how to insert or how to create a linked list, right? So we'll do all this programming in Java. So let's start with programming. So I'm doing in the Eclipse. So what do we want? Okay, so that we need to think first. So we want to create this one. So and it has the one node. So first we'll create each node. So and we'll take minimum set. So like this is an int. So one data variable will take integer and another will take a pointer. So pointer, here we have the node, right? So what we will do, we'll create a class node, and that class node has a one integer and another has again the itself variable, like node variable, right? So let's go to the here. So this is our main class. So we want disrupt it and now create another class. So let's say this is a class node. Sorry. So what we have said that in class node we have one integer, so that is an integer I, and we have another node, so we'll say it next, so that it's easy to recall. Okay, so this is our class node, right? And when we have the one, will create another class where we will define all the functions, all the methods of the which through which we can operate the linked list. So let's call it linked. Okay, and this is our main class. So what we will do, like this has the root node. Now this root node is pointing to the another node, so we'll always call the first element as root node, because in linked list we always traverse from the root node. So like later on we'll see the doubly linked list and the circular linked list, but in the single linked list we have always the root node, so we'll always keep the root node with us in the main class. So because in starting the root node is null, so let's say node root equals to null, right? So this is our root null. Now we want to insert element in that, right? So we'll say root. Now okay, first create an object of linked class, because this is a class where we will write all the functions. So first time giving you the symptoms that what we want actually, right? So we want to insert. So first create, let's say linked equals to new linked. So I have created an object. Now I want to insert. So what I will do, I will create a method there, insert, and where I will pass the value which I want to insert. So like in this case, let's say insert 12, and then I will pass the root, right? So this is a function insert. So I will create a function insert here. So let's create it as public and not void will pass the node, because we will return the node. So we'll always have the root, and say node and then insert, and this is integer, so let's say integer I, and this is node and then say it node, right? So because this is a starting of linked list, so we'll check that if our root is null, right? So because we are passing the root to this node, so we'll say if, we'll check if node equals to null. Now if node equals to null, so then we'll create a node, right? So we'll say that return get new node, and in that we'll pass the value I, because we want to create this node by using the integer I. So let's create another private function. So let's say node and get new node, and parameter is integer I. So we know that our node is node equals to new node, so through which we have created the memory of node. So once you do this, then it will create a node which will have the int I and node next, right? And then you pass the values. So int dot I equals to I, right? And then int dot next equals to null, because anyhow will, when we create a node, so we'll say that it next equal to null, right? Because it doesn't know right now that what is the next which is pointing to, so we'll say it null. Now return A, right? So once we'll give this, then it will return the get new node, and it will give us the node which will have the value int equal to I and next is null, right? So this is our first node. So and now let's say if our node is not null, right? So okay, first we'll create only the root node. So we'll start from the one by one. So and return null in case it is not null. Okay, I'll later explain, and I will later write the else condition, but first I'm starting with the root null. So like in the starting our root is null, I want to insert the 12 node, right? So it will go here, and it will say root equals to null, and we have created the object and root equals to a dot insert, right? So okay, so this is very good. I will debug it so that you can know that how we are going. So debug the Java application. Okay. Okay, so now go to F5. So it's saying it goes to here. Now what is I is 12 and node is null, because our root is null right now. So it will go here, it will check that node equal to null, yes. So it will go return get new node. So it will go to in the get new node function. Now it will create a node. So let's do it F6. So when you say A, so right now because when you create the object, so by default value it stores. So this is I equal to 0 and that is null. Now we insert the value A equal to 12 and this. So now we have I equal to 12 and next is null and return. So now again return the functions and here root. So now we know that our root is 12 and next is null, right? So that is the first node of the linked list. Now what I will do, I will insert the another elements. So let's say another element is 99. So again I will store the root at the end, and let's say insert, then give the value which you want to store. So let's say it's 99, and pass the root. Why root? Because we know that we have because root is always the linked list. This is the first root which is pointing to the whole linked list, so we are passing the linked list. So earlier we have only the one node, now we'll store the another node. So go here and let's see what we want. So now because our node is not null, so we want to check that what other options we have. So go to else, and now because our node is not null, so what you want in case of node is not null, so we'll start from here and we'll go through till we find that its next is null. Because whenever the next is null, then we can say that this is the last element of that linked list. This is the last node of that linked list. So first we'll find the next which is null, and then we'll create a node. And then we'll link this next to this node, right? And then we will return the root. So this is how we follow in the linked list. So okay, so do that else. Now node equals to, you check because this is the node, so you say when else node, and recursively we'll do this. So when node next equals to insert node next, and because this is I which we will pass, right, and here and return. So now what we can do, that this is node, so so here node dot next equals to insert I node dot next, right? So let's see that how it will work. So we'll change if we'll find anything else. So let's debug it. So we have debug point here. Okay, so debug Java application, click now. Okay, so what is root? Root is 12 null, which we have done in the first iteration. So now go to again this here, and now node is not null, right? So now we are saying that again call the function which is 99, because we are passing it. And what is node next? So node next is, if you say this, so what is that? This is node and the next is null, so we are passing null value, right? So go to again here, and now I is 99 and node is null, right? So when node is null, it will create a node which we want actually, because our next node is 99, so we'll create a new node. So go here and it will go again here, and it will give you new node. So now our node dot next is equals to 99, because now it will point, because the node is 12, right? So earlier it was null, but after this execution, the new node, it will point to the new node. So go here and you will see that now this 12 dot next is pointing to the 99, right? And then rather than this null, right, what we can do, that give here node, right? Because when we are doing recursively, then this node will always be the first node, right? So click give it as node and then run it again. So like debug and go here. Now this is not null. Okay, and now I'm doing F6. So this is node, node will always have the first value, and the next is 99, and this is null. Now it will return the function. So yeah, so now you will see the node is like 12, then the next is 99, then next is null, right? So let's again insert another value. So this is 37. The concept will be the same, but just I'm doing so that we again understand that whether we are doing right or not. Okay, terminate. Now let's put debug point here and again debug it. Okay, so till now our root is 12, then root is 99, and next is null, right? So do it F5, and then we know that our node is not null. Right now our node is our node is the first value, which is 12. So this is not null. So this will go in next. Now again it will call the insert, and it will call the node dot next, which is the 99, which was the second value. Now you can see the node is 99, right? And I is the value which you want to store. So again node is not null. Now again it will call the node dot next. So it will call the null, and now this is null, right? So now it will create a new node. So it will create a new node now. So we have created a new node, and now it will store the node. So node was 99, so it will store this next value null, so it will point to the new node, right? So go to F6. So now we'll see this, then we have stored the 37, right? So now return the node. So again, because we have recursively done this, so again it will return the node, and at the end it will return the first node. So if you see the node, this is 12, this is 99, and this is 37, right? So again we'll check that whether we are storing the value right or not. So we'll write a function print. So let's say a dot print list. So where we'll print all the items which we have added. So let's say print, let's terminate it. So create a function print list. So recursively we'll print the list. So we'll do the same concept, like if node equals to null, then it won't do anything. So it will return, else it will return, okay, remove this, else it will print the line, because we are starting from the so then it will print node dot I, right? And it will again call the function like print list and node dot next, right? So like we started from the 12, so it will check that 12 is not null, yes, so it will print 12, then it will point to the next item, which is the 99. Now it will go here, it will check that this is not null, yes, so it will print 99, and it will move to the 37, because the next is pointing to 37. Then again it will check that it will print 37, and the next is null. So when it will encounter that node is null, it will return. Okay, so now run the program, that whether this print list is giving correct value or not. Okay, so we haven't given the space. Yes, so again run the program, and you will see that now it is giving the correct value 12, 99, 37, right? And again, so like if you insert another value, so let's say after that, so this is, let's say 48. Now given the, insert the new line, and again and run the program again. Yes, save. So now you can see that it is giving the new value 2, right? So that is how we have created the linked list by adding the element at the end of the linked list, and that is how we have started the program. So in the next sessions we'll see more insertion, like insertion at the begin, insertion at the end, or insertion at the given positions. So thanks friends for watching the video. This was the starting tutorial of linked list, and please subscribe the channel for more such tutorials. So thank you.